Okay, then let's go from the current slide. I meant to do that first. Here we go. Now, we've talked about this. We've gone over this, but we're on example 3, which is chapter 2, polynomial and rational functions. We're in polynomial functions now. 2.1, just about finished with that, quadratic functions and models. And we're on the top of page 118, example 3. And the wording you see here is just above example 3. And I think what we'll do is start with the white page and do example 3, which means I'm also going to have to move some things around here. So hold on for a moment here and let me adjust my whiteboard. Okay. Now, no questions? So here's example 3. We have already done most of example 3. Here's what it was. Sketch the graph, and we haven't done that, but here's the function. F of x is equal to minus x squared plus 6x minus 8. Minus x squared plus 6x minus 8. There's the function we're supposed to sketch the graph. It says identify the vertex. We had already done that, and the x-intercepts. That's the part we hadn't done. So let's do a quick and dirty on what we did so far. Okay. Now, first thing we do, we need to get this function in standard form. Now, the first thing to do with standard form is factor out the a. Remember, the a is a coefficient of your quadratic term, the one with the exponent of 2. Now, we're only dealing with quadratic functions here. Well, the coefficient here is minus 1. So factor that minus 1 out of the x terms. Don't mess with the constant term, just the terms with x's in them. So that leaves an x squared here. And when you factor a minus 1 out of a plus, you get a minus 6x. Now, I like to leave a blank there, okay? And then I'll write my minus 8 here. Now, that's the same form as this. It just looks a little different. If you multiply through, you get minus 8 minus x squared plus 6x minus 8. We haven't changed anything but how it looks, okay? Next step. Leave that minus there. You factored that out. Now, what we're going to do is get this, complete the square of this term. Now, how do we do this? Take half of the linear term. Half of minus 6, okay, write down your x, okay, from here. Half of your linear term is minus 3, okay, the coefficient of the linear term. That's going to become your perfect square trinomial. Well, wait a minute, I skipped some steps, didn't I? Well, let's go back to this. Take half of the minus 6, that's minus 3, square minus 3, that gives you plus 9. Okay, so we've changed the problem now. That's different, very different. What we did, we added 9 here, but because of the minus sign out here, that subtracted 9. Well, to keep it the same function, you have to add the 9 back here. Now, if you went through this, you would see you still have the same function you started with. Minus x squared plus 6x minus 9 plus 9 is 0, minus 8. Yep, you're the same place you were before. Okay, now, I cheated a little bit and pulled the minus here, and as soon as you take half of this, write that number down here, minus 3, then square it. Okay, this is the perfect square trinomial for that binomial squared. Then add these two together, you get a plus 1. Well, what does this give you? This gives you your standard form. Okay, your vertex is going to be 3, 1. Okay, vertex is going to be 3, 1. It's the opposite of this one, exactly what that one is. There's your vertex. we answered the first part. We've already done that. Okay. Now, your A is -1, meaning it's opening downward. Whoops, here comes Jeremiah. I think it is. This is trying to darker out. Let's see if I can get Jeremiah here. Okay, Jeremiah's here. Let me make sure nobody else is waiting to come in. Yep, we got 13, and that's it. Let me make sure that was Jeremiah, because Zoom tries to block out. Yep, there's Jeremiah. I got her. Okay. So now we found the vertex, and I guess it's now time to sketch the graph. Okay, so I'm going to try to draw my axes. I'll try to make that one as vertical as I can, and I'll probably try to make this as horizontal as I can. Okay, now I know I need at least 3 here. 1, 2, 3, but I'll put 4, 5, 6, 7, 8, 9. Okay, I don't think I'll need those. -1, 2, 3, 4, 5, 6, 7, 8, 8, 9. I won't need all those, I don't think. Here we'll go up 1, 2, 3, 4. We won't need all those, and go down 1, 2, 3, 4, 5, 6, 7. Okay. Now 3 1's our vertex. Let's draw that in. Go 3 to the right and 1 up. There's your vertex right there. Now, as soon as you know that vertex, you also know your axis of symmetry. Now, I think I'm going to make the axis of symmetry red, because that's what the book usually does. The axis of symmetry. Okay, you know what that is. X equal 3. Take that X component there and make it X equal 3. Okay, so from here I will go due north and due south. That's my axis of symmetry. Why the pen's not writing, I'm not sure, but you get the general idea. That's the axis of symmetry. The vertex is always on the axis of symmetry. Okay, now what we haven't done that they ask us to do is identify the x-intercepts. So how do we get the x-intercepts? Well, let's go back to black here. And here it's easier. Go back to your original form. Not the standard form, the original form. And let's set that equals 0, because the x-intercepts are where y, which is f of x, is equal to 0. So minus x squared plus 6x minus 8, set that equal to 0. Those values for x that make that true will give you your x-intercepts. Now, here's something I don't like, and I usually try to adjust. Because this is equal to 0 here, you can do the same thing to both sides of the equation. And what I don't like is having a minus sign out front. So I want to change that to a plus, and of course you do that by either multiplying or dividing by -1. So I'm going to do that now. I'm going to multiply by -1. That will make this a plus, and make that one a minus. So since I have a little eraser symbol here, if I can get it to work, I will erase that and make it a minus. That's the same equation. Not the same function. We changed that, but it's the same equation because it was equal to 0. Okay, now we see if we can unfoil that, factor that. Oh, and here comes Ivan. He was here before. He must have had to bump out and come back in. I have a feeling with the storms last night, that the system may be a little shaky. I don't know if that's what it was, but it could have been. Okay. Now, what we're doing is, this is example 3 top of page 118, chapter 2, polynomial and rational functions. We're dealing with polynomial functions. 2.1 is quadratic functions and models, and we're dealing with example 3 on page 118. Okay, we had done some of this Tuesday. We are now doing trying to wrap up 2.1 and move into 2.2. So only possible factorization for x squared is x times x. Okay, next place we look is the sign of the last term. That's a positive. That means these two signs have to be the same. Well, are they both positive or both negative? Since the middle term is negative, we make them both negative. Now what we want is two numbers that multiply to be 8, add to be 6. I think that would probably be 4 and 2, right? Let's try it. X times x is x squared. That checks out. Minus 2x minus 4x, that's minus 6x, plus 8. That's it. That's equal to 0. And that gives us either x minus 4 is equal to 0, because you can't have two entities multiplied together to give you 0 unless one or the other of those is 0. Can't happen, okay? So it's either x minus 4 is equal to 0 or x minus 2 is equal to 0, okay? Well, guess what? If you add 4 to both sides here, you get x equal 4. If you add 2 to both sides here, you get x equal 2. There are your two x-intercepts, because your y was 0, f of x is 0, we set that equals 0. So here we have x equal 2 is 0, or x equal 4 is 0. You know, we're awfully close to having this knocked out, okay? We've got our vertex, 3, 1. We have our x-intercepts, 2, 0, and 4, 0. All we have to do is pick a few more points. Oh, a real easy one. Remember? Set x equals 0 up in the original form. That makes this 0 and that 0, and y is equal to negative 8. Can we get that on here? I don't know. There's negative 1, 2, 3, 4, 5, 6, 7. Let's just imagine we could get the 8 down here. Okay? There, x equal negative 8. Well, guess what? Since you're 3 to the left of the axis of symmetry, go 3 to the right of the axis of symmetry, and you're right there at negative 8 again. That's where the axis of symmetry is so useful. Okay? I don't think I went over enough, did I? Nope, it should be this one. Okay, I got that wrong. Somewhere right in there. That box is in the way. Okay. Now, it looks like to me, let's just pick one more point. How about x equal 1 or x equal 5? Okay? Either one of those. I sort of like 1 best. So let's put an x equal 1 here. So f of 1, and let's go on and use, either one of these forms would be good, but this one's a little easier. Okay? 1 minus 3 is minus 2, right? Minus 2 squared is positive 4. The negation makes that a minus 4, and then you add 1 to it, and you get a minus 3. So here's where we get 1 minus 3, and then using the axis of symmetry, this is 2 to the left, go 2 to the right, and there we have another point. Now you could go back and plug that in, you'll find the same answer. So here is our parabola. Oops, I can't draw very well. Make sure it's nice and smooth at the top, coming down here and going through this point here. There's your parabola. We've sketched it. We found the x-intercepts. X-intercept was 4, 0 and 2, 0. We got the vertex. We got the axis of symmetry. We've got it all. The a is negative here. -1, so that means it's opening downward. Everything fits. Any questions on that? Okay. Now in the book, they show that you shift it 3 to the right and 1 up from the origin here. They did f of x equal minus x squared, which would have been a function like this. Shift it left, right 3, up 1. Yep, we got it. I don't usually mess with that, but you certainly can. Any questions on example 3? Okay. There is a checkpoint like there is after every example. Please do the checkpoints. Okay. Now, they also are skipping example 4. So unless there's some question about this one, I'm going to delete it. Is that okay? All right, clearing the drawing here. Okay, let's do example 4. Now, this is a little bit different. Write the standard form of the quadratic function whose graph is a parabola. Of course it's a parabola. The graph of a quadratic function is a parabola with a vertex of 1, 2. Okay, so what we want, if I could get my pen to show up. Come on, there you are. Okay, the vertex is 1, 2. Okay, and it passes through the point 3, -6. This is just some point. Okay. Now, notice a difference here. Before, they gave us the equation. Then you had to find the standard form. This time, they give us 2 points. The vertex, very valuable point, and 1 other point. Okay, it's valuable, but not as good as the vertex. And they ask you to find the standard form of the quadratic function. They haven't given you the function at all, but you have to come up with it. Well, what is the standard form for a quadratic function? F of x is equal to a times x minus h squared plus k. Okay. Now, when they gave you the vertex, they gave you h and gave you k. So we already know 2/3 of that function. That standard function would be a, we don't know a, times x minus 1, that's your h, squared plus 2. Hey, 2/3 of the way there just using the vertex. Now, what we do now is use this other point to get the a. Well, the f of x is what? Always y. Okay, why not? Okay, y. So this is minus 6 is equal to, now we don't know a, that's what we're looking for. Okay, your x here is 3. So make it 3 minus 1 squared plus 2. We're just plugging in this xy value into this equation. Okay, the y is the f of x, the x is the x. Okay, 3. Okay, so let's solve this. That would be minus 6 is equal to, well, 3 minus 1 is 2. 2 squared is 4. So that gives you 4a plus 2. Hey, we can solve that for a. Let's subtract 2 from both sides. And that gives you -8 is equal to 4a, because these two add to 0, divide both sides by 4. And that gives you a is equal to -2. -8 divided by 4. So now we found our function in standard form, -2 times, okay, here comes Diana. Let me get Diana here. Okay, Diana's here. Okay. Let me make sure nobody else is trying to get in. Looks like we've got our 13 people, lucky 13. So let's make sure I've got 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whoa, we've lost some people. Okay. So evidently a few others have had to duck out, or else their internet's been unstable, because I have more than 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've lost 2 people. Hopefully they'll be back. Okay. So what? Yeah, something like that. Yeah. Okay. They got kicked out. I don't know. I can't tell what happened. Sometimes things get in the way and you have to leave and come back. Okay. So we found the a to b minus 2. So plug that in here. Then you had x minus 1 squared plus 2. There is your function in standard form. Without knowing what the original function was, anything about it, there's their standard form. Now what they do is proceed to graph it as well. They didn't say that, but we'll go on and do that since they did. So let's do our vertical axis here. Our horizontal axis probably up here somewhere. Okay, let's tick off a few points here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. Positive 1, 2, 3, 4. Negative 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now we know the vertex is 1, 2. It would be right about there. There's your vertex. And we know it has the point 3, negative 6 on it. There's 1, 2, 3, negative 6. 1, 2, 3, 4. Let's see. Let me do it this way. 1, 2, 3, 5, 6, and 3. I've already lost it. 1, 2, 3, 4, 5, 6. Go across here 3 spaces, and it looks like it's about there. Now, if you know the vertex is there, remember, excuse me, I'm so sorry. Excuse me. Again. Okay. Thank you. I'm glad y'all are awake now, right? Okay, never mind. Okay, thank you. You know the axis of symmetry is x is equal to 1. Okay, so I'm going to take my x-axis and go up from 1 and down 1. That's my axis of symmetry. Now, why did I even mess with that? Because you see 3, negative 6 is to the right of that axis of symmetry 2 units. So we know we have another point over here to the left of the axis of symmetry, right about there, x equaled negative. Whoops, I should have done that in black. Okay. There's another. Whoa, I thought I got black, but it didn't get, did it? Okay, there we go. Let's see. Yeah, there we go. Now we've got 3 points. We could sort of rough in a graph, okay? But hey, why not go on to your standard form here and put x equals 0? When x equals 0, you know you're on the y-axis. So you put a 0 there and do 0 minus 1 is minus 1. Squared would be a plus 1. Multiplied by minus 2 would be minus 2 plus 2. All that, and you wind up at 0. Well, use the axis of symmetry again. you're 1 unit to the left of the axis of symmetry, go 1 unit to the right, there's another point. And frankly, that's all we need. That's all we need. So let's draw in our parabola. Always make it smooth at the top. Come back down. My drawing isn't too good, but there's your parabola. And if you look in the book, they have a picture almost as pretty as mine, right? All they asked for was this, the function in standard form. We did a little bit more because they did also. They didn't draw in their axis of symmetry. I find this always a good idea too. Now, what they messed up in the book, if you look at it, at the very bottom of the example 3, they say this function in standard form, if f of x is equal to minus 2, good deal, and then they said x minus 2 squared plus 2. No, it's x minus 1 squared plus 2. And you know that because they gave you the vertex to begin with. That's a 1, not a 2. So if in your book you have a 2 there, change that and make it a 1. Okay. Any questions on example 4? All right. As with most of the examples, if not all of them, they follow them by a checkpoint. Please do the checkpoints as soon as you can after class. Okay. Now, let's go back to the PowerPoint. I'm so sorry. Let me get a drink of water or something here. It's water, okay. I had one of the best night's sleep I think I've had in weeks, and I'm still so tired and coughing and doing all sorts of things. I don't know what's going on. Okay, so let's go to finding minimum and maximum values. Let me go, if I can get the, for some reason, I don't know why, the cursor disappears. Okay, there we go. Finding minimum and maximum values, top of page 119. Okay. Many applications involve finding maximum or minimum values for a quadratic function, or any function really. By completing the square of the quadratic function, f of x is equal to ax squared plus bx plus c. That's the old way we used to write it. You can rewrite the function in standard form. Now, remember what the rules were? First, factor out the a from the x terms. So if you factor that a out here, you're left with an x there, actually an x squared, and then you have plus b over a. When you factor out the a, you get b over a times x blank. Let me fill in the blanks here. Okay, they just skip so many steps. Okay, so the first thing we do is factor out the a. That leaves us x squared plus b over a x blank plus c. Now that's the same form as we have here. If you do a times x squared, you get ax squared. A times b over a, the a's will cancel out. That would be bx plus c. Same thing. Okay? Then what's the next thing you do? You take half of this b term. Okay, I'm going to move it up here. So this will be a times x squared plus, wait, okay. Yeah, we'll leave it in there. Plus, I'm so sorry, b over 2a, because we've just taken half of it, x, okay, and then we square this. You take half of this and then square it. So that would be a plus b squared over 4a squared. Okay, close your parentheses. You already had your plus c here. I'm so sorry. What you've just done is I'm going to need another sip of water or something here. man, what you just done, when you added this, you added a times b squared over 4a squared. This a would cancel out one of those a's, and that gives you a b squared over 4a. You added that. Sorry. So you have to subtract that. Minus b squared over 4a. Okay? Now, this right here, remember this is where I usually did this. As soon as you take half of that, that gives you x plus b over 2a squared plus c minus b squared over 4a. Now that's using all letters, which makes it really confusing, but guess what? This is the standard form for this equation. Now, do we want to do that every time? No, we'd much rather use numbers, but here's something to notice. Your your h value here is just b over 2a. Remember that. The h here is b over 2a. That's the thing to remember from this, okay? And here you have it, a times x minus h. I'm sorry, that's a minus b over 2a, okay? Because that's a plus there. Remember, the x's are always opposite. Minus b over 2a squared. And then, who cares about this, okay? We sort of do, but we don't need that. That's your k, but that's so complicated. Forget that. Just remember, your h value is minus b over 2a. That's what they're getting for. Getting at, I don't know. So the vertex of the graph is minus b over 2a, that's the x value, and then rather than remembering all this mess for your h, just plug in f of minus b over 2a. Just plug it into the original function here, okay? I can't get my pen to move, there it goes. Just plug in minus b over 2a for your x, and you're going to get your y, okay? So, sorry. So this implies the following. The minimum and maximum values, guess what? Your vertex is always either the minimum value if a is positive, the maximum value if a is negative. So, without having to reinvent the wheel or even go through all that getting it in standard form again, all you have to do is consider the function f of x equal ax squared plus bx plus c. We're used to that. And you know your vertex is minus b over 2a. Right there. And then once you find out that's your x value, your h value, then plug that value in here and see what your y value, your k value is. Okay? Now, when the a is positive, that's a minimum because your parabola is opening upward. Okay? And the minimum value is that f of minus b over 2a. Okay? When the a is negative, though, then you know it's opening upward, and that has a maximum value when x is equal to minus b over 2a, and the maximum value is f evaluated at minus b over 2a. Now, I'm going to give you another little hint here. I don't know if you remember this from earlier math. When you are solving your quadratic formula, if you remember what that was, x was equal to, from this form here, if this is equal to 0, your quadratic formula was minus b plus or minus the square root of b squared minus 4 ac divided by 2a. Okay, now I want you to look at something here. Look at the first term, minus b over 2a. there is the same thing we have here, your h value, minus b over 2a. And then you either go plus from that or minus from that, but that's your vertex. X equal, the h value is minus b over 2a. You've seen it before, you'll see it again. That's what you have. And then to find out the y value, either the maximum if a is negative, the minimum if a is positive, then you just plug minus b over 2a into your original function and go for it. Now, do you have to use the letters minus b over 2a? No, just calculate what they are, plug them in. Okay, so here's example 5. The path of a baseball after being hit is given by the function f of x is equal to, wow, what a number, negative 0.0032 x squared plus x plus 3. Now, this f of x is the height of the baseball in feet, okay, how high you have hit it, okay, in feet. X is the horizontal distance from home plate, again in feet. Now the question is, what's the maximum height of the baseball? Well, it's going to be a max or a min. It's going to be a max, because look at here. Your a is a negative number. It's a really small negative number, but your a here is negative 0.0032. Okay? Now, I'm going to give you a little hint here. You don't need to know this, but this is given in what we call U.S. customary, because you're dealing with feet, not meters, and so your acceleration due to gravity in feet per second squared is 32 feet per second squared. So that's where the 0.0032, now it's a little bizarre, but it's there. Now, the x, the coefficient for x, has to do with the velocity with which you hit the ball. We're not even given that, so don't sweat it. But if you think about this, when x equals 0, you're right there on home plate. Well, where did you hit the ball? 3 feet off the ground, because this is the height at any point x. So when x equals 0 at home plate, you're 3 feet off the ground. That's just about waist level. Now you've hit that fly ball somewhere out there. Okay, so this sort of makes sense. Okay, now let's identify the other elements here. Your b here, the coefficient of x, is just merely 1. And you could, if you wanted to, say c is equal to 3. Guess what? We're not going to use c at all. Okay? So what's the first thing we do? We figure out the h value, the x coordinate of your vertex. That's going to be where that maximum height is. That's not going to be the maximum height, but it's going to be where it is. So what is that? The h is equal to minus b over 2a. Remember that? That's what we did before. Okay, now all you have to do is plug it in, plug it in. And if I could get my pen to show back up, there it is. Okay, so it's a minus 1 over 2 times 0.0032, except I left off my minus sign. Okay, there's a minus sign there. That's pretty ugly, isn't it? Okay, so this would be, you have a minus here and a minus there, so that's going to be a plus 1 over 0.002 times 32 is 64. So it might be a good time to pull out your handy dandy calculator. I'm using my phone, and do that. Okay. If I can get my calculator to come up. Unable to install calculator. Evidently, my Wi-Fi signal must not be very good. Ah, there it came up. Okay. 1 divided by 0.0064 equal 156.25. Did anyone else get that? Okay. So there is your H. Okay, what does that mean? 156.25 feet from home plate, that ball's going to be at the maximum height, 156.25 feet. That's how far from home plate it'll reach its maximum height. That's a pretty well hit ball. Okay, now what is the maximum height? That didn't give you the maximum height. That gave you where the maximum height was from home plate. So what is the maximum height? Well, we'll take our f of, this is an x value, remember your h, 156.25 is feet. I'm probably not going to write that in. Will be negative 0.0032 times your 156.25 squared, okay, plus x is 156.25 plus 3. You just plug in this value, the x value for the h, into your function. That gives you your maximum height. So again, I'm going to pull out my calculator. I wish I'd have left it on. Okay, that was 156.25. Okay, I'm going to square that. Oops, I better turn it sideways to get it to scientific notation. Square that. Okay, big number. Multiply that by a 0.0032, but I have to negate that because that's a negative. So I have to do a plus minus key there. Negate that. Plus 156.25, 156.25 plus 3. I got that the maximum height of that ball was 81.125 feet. Okay, so we got the maximum value to be 81.125 feet. That's how high it went at its maximum height. After that, it's going to start coming down. The question is, will it pass, go over the fence? Okay, well, I'll give you a hint. It's really close to another 556.25 feet. That's how far it'll go before it's 3 feet again, okay, because of the axis of symmetry and that kind of stuff. And that's going to be 312 feet from home plate. If you hit it well, that's probably going over the fence. If not, they may catch it on the warning track. Okay. Any questions? Okay, let's see how the book did it. I'm going to clear mine out of the way. Okay, so let's clear my writing here, and let's see what they did. From that quadratic function, here's what it is. The a is negative 0.30032, b is 1, c is 3. We're not going to use the c, but it's okay. You can identify. Okay, so the a is negative 0.0032, b is 1. Notice they didn't even mess with the c because they're not going to use it. Let me make sure there's nobody else trying to come in. We're down to 10 students now, so we're losing people pretty fast. Sorry about that. Okay, it may be internet is poor, I don't know. Okay, so, or people are ducking out, aren't they? Okay, so let's figure out how far from home plate that maximum height is going to be. Well, that's minus b over 2a, which will not advance. I don't know why this does this. There we go. Because a is less than 0, a negative number, the function has a maximum height at minus b over 2a. Remember that, okay? So the baseball reaches its maximum height when it is that far from home plate, minus b over 2a. So let's start plugging in the numbers there. So minus 1 over 2 times a negative 0.0032. They remember their negative sign. Okay? And that gave us 156.25 feet from home plate, exactly what we got. Okay? Now, that still doesn't give you the maximum height. That tells you how far you were from home plate when it reached the maximum height. So what we have to do now is plug this value in to your original function. Okay? And at that distance, the maximum height is f of 156.25, which is minus 0.0032 times 156.25 squared plus 156.25 plus 3. That was your original function. Just plug in this x value. Okay? And when you do that, they don't show you how you got it, but that's 81.125 feet. That's how high the ball was at its maximum height. At that point, it's going to start coming down again. Up before that, it was rising to that point. Now it's going to come down, and somewhere about 312 feet from home plate, it's going to be back about 3 feet off the ground. Okay? So whether it clears the fence or not, we're not sure. We weren't asked that. Any questions on that? There's example 5. Now, that's the last example. There is a checkpoint, as always, so please, sorry, do the checkpoints. There is a little summary there. Never a bad idea to look at the summary. Let's now do the vocabulary. This is the top of page 120. Okay? Fill in the blanks. Say again? Yes. Okay. Do you have a book? The e-book? Is that what you're trying to say? Okay, yeah, when you are on Cengage Unlimited, you have access both to an ebook and to WebAssign. Now, you can use either you want to, both of them if you want to. They're yours for the doing. You paid for them, okay? Use them, okay? In the ebook, then, I don't know how they numbered the ebook. I don't know if they put the page numbers or not, but hopefully you can find in the ebook section 2.1, right? Okay, at the end of section 2.1 in the physical book, okay, it's on page 120. I don't know if the ebook numbers them that way, but if you find the 2.1, do the exercises at the end. There are your, that's the problems I'm assigning. If you don't want to use those, you certainly can use the WebAssign. I don't care. It's up to you. You just need to practice the problems, okay? Whichever ones you use. Yeah. Is that,
So I can do the WebAssign and it's still gonna get graded.
yes. You just have to give them to me. And you've been sending them to me fairly regularly, and they're showing up on the homework, week 3 homework, week 5 homework, week 9 homework. When you send it to me, I try to post that on the Blackboard. It's under the grade book, but it's not a score. It's just a posting. 0 points, but it's posted. That means that I've acknowledged the receipt. And usually I send you something on that, either just the posting, or if you send it to me through an email or a Blackboard message, I'll send you something back. If you send it to me through the weekly activity there that says homework, week 4 homework or week 7 homework or whatever, then I just mark it on that. And when you see the 0 there, that doesn't mean you get a 0. That means I've acknowledged your receipt. There's no points for it, but it's acknowledged that you received it, that you submitted it. Okay, so say again. Okay, whether you send it, I think you've been sending WebAssign, and I'm trying to recall, do you send that through an email or do you send it through Blackboard message or do you send it under the week's homework? Okay, however you send it to me, if you send it to me through Blackboard message or an email, either one of those, then I will respond to you and say I've received this, I've marked it, put it in my grade book, and I'll post it on Blackboard when I can. If you send it to me in the week's activities, and here comes Janae, she must have had to duck out and come back in, but I've already got Janae here, I'm pretty sure. Yep. Okay. If you do it through the week, say this week is week 11, I believe it is. Week 11 homework under the week 11 tab. And if you send me that, your WebAssign or whatever it is, then when I see that, I will post the grade of 0. I won't send you a message because you'll see that immediately. If you send it through an email or a Blackboard message, then you may not see it immediately because I have to grade it separately and then put it in the Blackboard, put it in the grade book. So in that case, I will actually send it to you, say I've received this, noted it in my grade book, and I'll post it on Blackboard when I can. Okay, so either way, it gets posted. Does that make sense? All right. Okay. All right. So we're on page 120, chapter 2, 2.1. Chapter 2 is polynomial rational functions. 2.1 is quadratic functions and models. We're doing the vocabulary at the top of page 120. If you have your ebook, hopefully you can find that. Fill in the blanks. 4 questions here. Some have more than one blank. The first one, linear, constant, and squaring functions are examples of blank functions. Okay, linear, constant, or squaring functions are examples of, hint, look at the title of chapter 2, the first part of it. Polynomial functions. Linear functions, constant functions, and squaring functions are all examples of polynomial functions. Number 2, a polynomial function, there it is, of x with degree n has the form of f of x equal a sub n, that's the coefficient of your nth power, x to the n, plus a sub n minus 1, that's the coefficient of your n minus first power, x sub n minus 1, plus a sub n minus 2 times x to the n minus 2, and you keep on counting down till you have a sub 3, x cubed plus a sub 2, x1, x squared, plus a sub 1, x, plus a sub 0. That's your polynomial function of degree n. Now, the requirement here that a sub n, that very first coefficient, cannot be 0. Okay? Cannot be 0. All the rest of them, any of them could be 0 or anything else. The a sub n can be anything in the world except 0. Real number. Okay? Where n is a blank blank. Okay? Now, what do we mean by blank blank? I'm going to suggest you turn back one page and you'll see, well, you don't really have to turn back, maybe you could. Positive integer. Your n's are positive integers, and it looks like maybe someone's trying to come back in. Let me see. Nope, I don't see anybody. Maybe someone left. Okay, sorry about that. Okay, so n is a positive integer. A can be any real number in the world, except a sub n can't be 0, but any other real number. But the n is only a positive integer. Now, those coefficients, a sub n minus 1, a sub n minus 2, a sub n minus 3, all the way down to a sub 3, a sub 2, a sub 1, a sub 0, those are, like I just said, any real numbers, as long as a sub n is not 0. Number 3, a blank function is a second degree polynomial function and its graph is called a blank. Hopefully you know that one. What's the title of section 2.1? A blank function is a second degree polynomial function. Quadratic function is a second degree polynomial function and its graph is called a parabola. Yes, very good. Okay. Number 4. When the graph of a quadratic function opens downward, the leading coefficient is blank. When the graph of that polynomial opens downward, that parabola opens downward, that means the leading coefficient, that a sub n, is negative. Okay? And the vertex of the graph is if it's opening downward, that vertex becomes your maximum value. All right, there was your vocabulary. Now, I would suggest try to work all 4 of 5 through 8. Now, only the answers are in the back of the book for 5 and 7, and they're also at Calc Chat 5 and 7, but you should be able to match up all of those 5 through 8. Okay, the 5 and 7 are at Calc Chat. Then do any of the odds, either 9 or 11, both at Calc Chat. 9 is at Calc View. Then do any of the odds 13 through 25, they're all at Calc Chat. 17's at Calc View. Do any of the odds 27 to 33, they're all at Calc Chat. Okay, and it says you may need a graphing utility on some of them. I think you can do them without, but if you need it, use it. 35's at Calc Chat. Any of the odds 37 to 45 should be at Calc Chat. 37 should be at Calc View. 47 and 49 should both be at Calc Chat. Any of the odds 51 to 55 should be at Calc Chat. 57 to 61 should be at Calc Chat, with 57 at Calc View, and 63 or 65 should be at Calc Chat. Okay, 67 through any of the odds 67 through 73 should be at Calc Chat. True false 75 should be at Calc Chat, and you can think about doing 77. It should be at Calc Chat. 79 and or 81 should be at Calc Chat. Any questions on 2.1? Okay. If not, I'm going to get out of 2.1. If I can get, there we go. All right, I'll close that out and try to find 2.2. Okay. Now I opened it earlier. There it is. Is it? How in the world could that happen? Okay, sorry about that. We will start 2.2 next time. Okay, you got your homework exercises here. We'll move on 2.2. Hopefully, it's a fairly long section. Hopefully we'll make good progress on it next Tuesday. And remember, the question did come up earlier. Do we have class on Tuesday? Yes, we do. If you need to vote, please vote. Okay, I'll record the class just like I've recorded this one, and we will you should be able to pick up on it. Okay, come in when you can, whatever. Please vote though. Okay, any last thoughts, any questions?
Shamari said her connection went out.
I see.
Come to
Okay, I think I, okay. Oh, no, yeah, I got her. She was here at the very beginning. So I got her marked present, but she'll have to pick up on the YouTube videos and see what the class was about. Okay, thanks for telling me though. I figured today was going to be pretty spotty with all the storm that we had last night. I slept through most of it, but it sounded like it was pretty bad. Okay, but thanks for telling me. Okay, so I'm going to, let's go on and end the PowerPoint, and I'm going to end the sharing here. So take care, people. Have a good weekend. Be very safe. Be careful. The virus is still going rampant out there. So please be careful. Okay? Take care of yourselves. Okay, if there are no further questions, I'm going to end the meeting. People are leaving already. Take care. We'll see you on Tuesday. Bye-bye.
All right, you have a good weekend, Mr. Bowden.
Thank you so much. Bye-bye.